Welcome student. In this class we will discuss pressure factor. As we have already discussed the temperature, in my class I had clarified that there are three factors affecting the atmospheric condition. First is temperature, right, which is also associated with insolation. Second is pressure, and third one is humidity, that is water content of the air. What is pressure? So as far as the question of pressure is concerned, pressure is defined as the weight of one column of air, and it is expressed in terms of millibar. Getting well now? On the Earth's surface, you see, there are two extremes of the atmospheric pressure, right? The minimum atmospheric pressure so far recorded on the Earth's surface is considered to be 877 millibar, and it was recorded at the eye of the tropical cyclone in Pacific Ocean near Philippines. Okay, and highest atmospheric pressure so far recorded is 1082 millibar. These are the two extremes. This is minimum atmospheric pressure and this is maximum atmospheric pressure. Getting well now? And 1013 millibar is considered as average atmospheric pressure, right? 1013 millibar is referred to as average atmospheric pressure. Getting well? So we should have the idea about what is the minimum atmospheric pressure, what is the maximum atmospheric pressure, and what is the average atmospheric pressure. And you must keep in mind one thing: if pressure will be more, then there will be negative change in the sea level. If pressure will be less, then there will be positive change in the sea level. So the level attained by the sea, when average atmospheric pressure of 1013 millibar operates, is referred to as average mean sea level, and this is considered as the basis for determination of height and depth of any landform. Getting well? Now see, as far as the question of temperature is concerned, so according to the gaseous law, you know, according to gaseous law, we have, according to gaseous law, you know that temperature is inversely proportional to P, right? On the Earth's surface, we know that there is a latitudinal distribution of insolation. That is, equator is the zone where highest insolation is recorded, and in the, here angle of insolation is almost 90 degrees. And as we move towards the pole, now, angle of insolation gradually decreases, and hence, since you know that angle of insolation is proportional to heating effect, so that's why from equator to the pole, negative trend of temperature is recorded. Getting well? In both the hemispheres. Getting well? And since you know that temperature is inversely proportional to pressure, so that's why it is normally expected that when you will move from equator to the pole, the pressure will gradually increase, right, in poleward direction in both the hemispheres. This should be the normal, this is the normal expected trend of population as well as pressure. Getting well now? But actually you see, this position is not actually maintained on the Earth's surface. On the Earth's surface, we have alternate distribution of high pressure and low pressure. 7 pressure belts exist on the Earth's surface, and they are, and high pressure and low pressure are alternatively arranged. Getting well? You see, suppose this is our surface. This is our surface. So at the equator, we have 7 pressure belts on the Earth's surface. Technically, this is 0 degree. This is 0 degree. This is 10 degree north. 10 degree north. This is 10 degrees south, 10 degree south. This is 0 degree. Again, this is 23 and this is 25 degree north to 35 degree north. Since there is latitudinal distribution of temperature, at the equator, the angle of insolation is maximum. That's why the highest temperature is recorded. And as one moves gradually towards the pole, the angle of insolation gradually decreases. In this case, as one will move from equator to the pole, the temperature is expected to become negative. That is, gradual decrease in temperature is expected in both the hemisphere. Getting well now? On the other hand, since you know that temperature is inversely proportional to P, so in this case, it is expected that pressure will gradually increase, right, when we will move towards the poleward direction. Getting well? What is the actual trend? It is clear now? So this is the expectation on the surface, that at the equator the pressure will be minimum because temperature is highest, and at the pole the pressure will be highest because temperature is minimum, and hence there should be a regularity, descending trend or decreasing trend of pressure, increasing trend of pressure from equator towards the pole as P is inversely proportional to T. But this not actually happen. There exists 7 pressure belt on the Earth's surface, and one is high pressure and second is low pressure, and these pressure belt are alternatively arranged. Getting well? You see on the Earth's surface what is the actual position. The actual position is, suppose this is Earth's surface, okay? This is 0 degree, this is 10 degree north, 10 degree north, and this is 10 degree south, 10 degree south. Getting well? Second is 25 to 35 degree, 25 degree north to 35 degree north. Next one is 60 to 65 degree, 60 degree north to 65 degree north, and ultimately this is 90 degree north. Getting well? In southern hemisphere we have 25 to 35 degree, 25 degree south to 35 degree south. Okay, near the pole there is a 60 to 65 degree, 60 degree south to 65 degree south, and this is south pole, 90 degree south. Getting well? And this is 90 degree south. Okay, so we have first pressure belt. This is located in the middle of the Earth near the equatorial zone, and it is referred to equatorial low pressure belt. Okay, equatorial low pressure belt exists between 0 to 10 degree north and south. Getting well? This second belt is referred to as subtropical high pressure belt, and this is also subtropical high pressure belt. Okay, this is the third belt known as subpolar low pressure belt, and this is also subpolar low pressure belt, subpolar low pressure belt. Okay, and near the pole there is a polar high pressure belt in both the hemisphere, polar high pressure belt. Getting well? So we have 7 pressure belt. First is between 0 to 10 degree north and south, and the 0 to 10 degree north and south, and this is referred to as 0 to 10 degree north and south, and this is referred to as equatorial low pressure belt, 0 to 10 degree north and south, and it is referred to as equatorial low pressure belt. Second zone is, its number is 1 as it is located in the center. Second is between 25 to 35 degree north and south. Okay, this is subtropical high pressure belt. Okay, this is the third one, its number is 2 in northern hemisphere as well as southern hemisphere. Number third is located between 60 to 65 degree north and south, right? It is referred to as subpolar low pressure belt, right? And near the pole, you can say between 70 to 90 there is degree north and south, there is a polar high pressure belt. So actually its number is 2, its number is also 2, right? So you see we have one equatorial low pressure belt on the Earth's surface, one equatorial low pressure belt on the surface located between 0 to 10 degree north and south. Second is subtropical high pressure belt located between 25 to 35 degree in both the hemisphere, 25 to 35 degree latitude in both the hemisphere. Getting well now? Its number is 2. Okay. Again, there is third pressure belt located between 60 to 65 degree. This is subpolar low pressure belt in northern hemisphere and also in southern hemisphere. And there is a high pressure belt near the pole. Getting well? So this is first, this is low pressure belt you see. This is low pressure, this is high pressure, this is low pressure, this is high pressure. Low pressure, high pressure, again low pressure and high pressure. Getting well? So we have alternate arrangement of high pressure and low pressure belt on the Earth's surface. Total number of pressure belt on the Earth's surface is 7. Okay, the pressure belt existing in southern hemisphere are more continuous because of the homogeneous nature of the surface, as southern hemisphere is dominated by water. On the other hand, this is not so much continuous in northern hemisphere because there is unequal distribution of the land and the sea in the northern hemisphere. Getting well? So what is the actual position? It is clear. We have 7 pressure belts on the surface and these pressure belts are alternatively arranged. Getting well? Now see, one should keep in mind one important point. I think that you have already noted this, but you see, as far as the question of pressure belt is concerned, pressure belt on the Earth's surface, it is clear that there exists 7 pressure belt on the Earth's surface. One is low pressure and second is high pressure. Getting well? In alternative way. Getting well? Now see, as far as the question of number of pressure belt and their nature is concerned and cause of its formation is concerned, so you must keep in mind that some pressure belt are due to thermal factor, or origin of some pressure belt can better be explained on the basis of thermal factor. So this pressure belt is referred to as thermally induced pressure belt. Okay, but there exists certain pressure belt on the Earth's surface which cannot be explained on the basis of thermal factor. This because it is not in conformity with the temperature factor, because you see, if the temperature is high, then low pressure is expected, but there exists high pressure. So this not matches with the thermal factor. Okay, or if temperature is low, then high pressure is expected, but there exists particularly low pressure in this area. So such type of particularly pressure belt, this is the condition on the surface. So some pressure belt, origin of some pressure belt can be explained on the basis of thermal factor, and these pressure belt are referred to as thermally induced pressure belt. Okay, you see this number 1, that is equatorial low pressure belt, right? Equatorial low pressure belt, this is number 1, and this is polar high pressure belt. Okay, so actually in equatorial zone temperature is high, that's why pressure is low. And in polar zone the temperature is low, that's the pressure is high. So you can explain the origin of equatorial low pressure belt and polar high pressure belt exclusively on thermal factor. Getting well now? So that's why equatorial low pressure belt and polar high pressure belt is referred to as thermally induced pressure belt. On the other hand, you see this pressure belt, 23.5 degree, 25 to 35 degree latitude, is referred to as subtropical high pressure belt. So this pressure belt is located closely to 23.5 degree north and south in both the hemisphere, and this is referred to a line of tropics. Line of tropics is considered as the warm zone. Okay. In this case, if the temperature is high, then low pressure is expected there, but against this there exists the formation of high pressure in this zone. So this is referred to as, you cannot explain the formation of subtropical high pressure belt on the temperature factor. So this pressure belt is referred to as dynamically induced pressure belt. Okay. Again you see, there exists a pressure belt which is 60 to 65 degree latitude in both the hemisphere. This is referred to as subpolar low pressure belt. Okay, this pressure belt is very close to 66.5 degree north and south. These lines are referred to as polar circle. Okay, in northern hemisphere it is referred to as Arctic circle, and in southern hemisphere it is referred to as Antarctic circle. These are low temperature zone, and hence high pressure is expected to form there. But opposite to this, there exists the formation of low pressure in this zone. So again, this is dynamically induced. This is dynamically induced low pressure belt. Getting well? This is dynamically, and this is dynamically. It means we have two thermally induced pressure belt in the form of equatorial low pressure and polar high, and two dynamically induced low pressure belt in the form of subtropical high pressure belt and subpolar low pressure belt. Getting well? In totality, there exists 7 pressure belt on the Earth's surface found in alternative way. Getting well? Now see, you should keep one important point in your mind. What factor causes the origin of low pressure and high pressure? So when there occur upliftment of the air, then low pressure is created on the surface, and low pressure is characterized by cyclonic condition, and in this case cloud formation is favored and the area may receive rainfall. Getting well now? On the other hand, when there occur downward descending tendency, descending column of the air current, in this case high pressure is created, and in high pressure anticyclonic condition prevail, and it not favor the cloud formation, and hence low rainfall is expected in this zone. Getting well now? So we have two conditions on the Earth surface. One is low pressure and second is high pressure zone on the Earth surface. Getting well? One is high pressure and second is totally low pressure. Okay? So we have actually, now we will discuss one by one. Actually, you see, if I am drawing a figure, if you will understand this figure, then maths will be very close, very clear, right? Actually, these are the pressure belt on the surface, right? How many pressure belt? Now it is clear. 7 pressure belt existing in alternate way. Okay? You see, if this is one pressure belt, right? This is 0 degree, this is 10 degree, and this is 10 degree. This is 10 degree north, this is 10 degree south. Okay? Again, this is 25 degree north, and this is 35 degree north. Right? This is 60 degree north and 65 degree north, and this is 90 degree. Okay? In southern hemisphere, we have 25 degree to 35 degree. We have 60 to 65 degree south. This is the southern hemisphere. Getting well? And near the pole there is a 90 degree. Getting well? So actually you see what happened. What causes the formation of low pressure and high pressure? I have said that when there occur upliftment of the air, then low pressure is created, and if there occur descending column of air current, then it causes the high pressure. You see, this is low pressure, this is low pressure, this is low pressure. Certainly they are associated with the ascending column of air current. This is high pressure, this is high pressure, and this is high pressure. Certainly they are associated with the descending column of air current. So you see, the wind from this zone uplift, divert here, descend between 25 to 35, forming particularly high pressure belt. Okay? Again, this is low pressure, the wind uplift in this direction, divert here, descend here, and return back. Right? Here particularly you see, that's why low pressure is created. From this low pressure, again the wind descend, divert, and in this way you see, again this component divert in this direction, descend here to form a cell. This is low pressure, the air uplift, descend here and return back. Same is the condition here in southern hemisphere. Getting well now? So we have, you see, if this is northern hemisphere and this is southern hemisphere. So from this figure it is clear that whenever there occur upliftment of the air, it causes the low pressure. That's why it is equatorial low pressure belt. And since the air descend along 25 to 35 degree latitude in both the hemisphere, in northern and southern hemisphere. So that's why high pressure is created. Again, in between 60 to 65 degree latitude, there occur upliftment of the air, okay, causing low pressure, and near the pole there occur descending tendency of air current, and hence high pressure is created. So what is the actual scenario? It is clear, right? Why particularly low pressure is created and why particularly high pressure is created on the Earth's surface. We have two examples of this. It is clear now. One is high pressure and second is particularly low pressure system. Getting well? Now I am discussing, you see, equatorial low pressure belt. The equatorial low pressure belt exists between 0 to 10 degree north and south. It is thermally induced pressure belt. Getting well? Due to high temperature conditions prevailing there, the Earth's surface remain warm, and whenever the atmospheric air come in contact with it, it become warm and uplifting upward direction. Getting well? So since the surface is warm, that's why intense convectional phenomena occur in this zone. And in convection process, you know that wind uplift when it is warmed up. You getting well now? And upliftment of the air causes the formation of the low pressure in this zone. So what is 0 to 10 degree? What is the character of the 0 to 10 degree north and south? It is clear now? So 0 to 10 degree north and south is referred to equatorial low pressure belt, okay, because of the upliftment of the air induced due to thermal factor. Getting well? 0 to 10 degree, the central part of 0 to 10 degree north and south is referred to as doldrum, right? Broadly it is considered that doldrum exists between 0 to 5 degree, right? This zone is referred to as zone of calm, and you see in this zone there is actually शांति की पेटी के नाम से जानते हैं इसको, and this zone is characterized by variable nature of wind. Getting well, winds are highly variable. That's why it is also referred to as doldrum. Okay, in this zone there is absence of the wind and there is a dominance of air current in doldrum area. Getting well now? And you see what happens if this is 0 degree and this is 10 degree, this is 10 degree and this is 10 degree. The wind comes here and uplift now. So this central part, this is doldrum, 5 degree to 5 degree, okay, doldrum area. Okay, it is the central part of the equatorial low pressure belt. Getting well? Now see, 0 to 10 degree, that is equatorial low pressure belt, is also referred to as intertropical convergence zone, that is ITCZ, because two trade winds, one trade wind of northern hemisphere and second trade wind of southern hemisphere, converge between 0 to 10 degree north and south. Since trade wind is the tropical wind, they converge between 0 to 10 degree north and south. That's why 0 to 10 degree north and south is referred to as intertropical convergence zone, that is ITCZ. Getting well now? And you see, since 0 to 10 degree, that is equatorial low pressure belt, is associated with thermal factor now. So with northward and southward of the shifting of the sun, there occur the shifting of ITCZ in both the hemisphere. The shifting of ITCZ is more in northern hemisphere as compared to that of the southern hemisphere, because in southern hemisphere there is a dominance of water, whereas in northern hemisphere there is a dominance of land part, and you know that a specific heat of the land is less as compared to that of the specific heat of the water. Getting well now? Actually, a specific heat of water is 2.5 times more than that of the specific heat of the continent. That's why continents are warmed up, and hence particularly you see, that's more warmed up, and hence shifting of ITCZ is more in northern hemisphere as compared to that of southern hemisphere. Okay. Again, you see, flow notice that the shifting of ITCZ is not uniform even in northern hemisphere. In northern hemisphere, the ITCZ shift broadly up to 20 degree north in Africa, but shifting of ITCZ is maximum over Indian subcontinent because of the presence of Himalaya. India holds tropical climatic condition, right? And the shifting of ITCZ is recorded up to 35 degree north latitude in India. Okay, so this is favorable. The more shifting of ITCZ over Indian subcontinent is favorable in context of monsoon and rainfall. Getting well now? Flown said that ITCZ not shift universally every time in India up to 35 degree north. Sometimes it shift up to 35 degree, but sometimes it shift only up to 70 degree. When ITCZ shift only up to 35 degree, then intense rainfall is recorded and Indian rivers are flooded. But when shifting of ITCZ occur effectively only up to 70 degree north latitude, then rainfall is adversely affected and India suffers from drought-like condition. Okay, so what is the actual position? It is clear now. So on the basis of ITCZ theory, one can explain the flood and drought. Okay, flood and drought-like condition can be explained on the basis of ITCZ theory. Getting well now? Now see, what is equatorial low pressure belt? It is clear. An intense equatorial low pressure belt, right, is characterized by very high temperature and high rainfall. Right, both the conditions are suitable or considered ideal for the vegetation growth. That's why evergreen equatorial forests are found here. Since the density of forests are very high, that's why there is a keen competition among the plant to get direct solar radiation. That's why they increase their height. Okay, that's why there is a dominance of avian in the equatorial low pressure belt. Getting well? Second zone is subtropical high pressure belt existing between 25 to 35 degree latitude in both the hemispheres. I have already said that this is very close to that of line of tropics, and hence line of tropics is warm. In this case, low pressure is expected there, but against this assumption, we have high pressure formation in this zone. Okay, so this cannot be explained on the basis of thermal factor. This can better be explained on the basis of on the dynamic factor. That's why 23.5 degree. That's why a subtropical high pressure belt is referred to a dynamically induced pressure belt. Getting well now? You see the wind from both the sides, from both the low pressure, descend in between 25 to 35 degree north and 25 to 35 degrees south, creating high pressure zone in this area. Okay, because of the subsidence of the air, high pressure is created, and descending tendency of air causes anticyclonic condition. And you know that in anticyclonic condition, not favor the cloud formation. That's why most of the world deserts are located between 25 to 35 degree latitude in both the hemispheres. Getting well now? And subtropical high pressure belt is also referred to as horse latitude. Getting well? Right? So what is the characteristic of subtropical high pressure belt? It is clear. You see 25 to 35 passes through India. In this case, particularly you see broadly very low rainfall is expected, but Indian condition is modified by the monsoon. Okay, but in fact you see third desert is located in this belt. Getting well now? Most of the world deserts are located, mostly particularly located in the western part of the continent, are mostly particularly desert-like. Okay. Now see, the third belt is, next belt is between 60 to 65 degree. This is subpolar low pressure belt. So subpolar low pressure belt again is dynamically induced low pressure belt. Getting well now? Because it is located near polar zone, and in polar zone low temperature condition and a polar cell, and near polar cell low temperature condition prevail. But in this condition, high pressure is expected there. Right, but against this there occurred the formation of low pressure belt in this area. So actually origin of subpolar low pressure belt in both the hemispheres can better be explained on the basis of dynamic factor. Okay, there are two explanations given by the climatologists for the origin and development of this subtropical subpolar low pressure belt. One is due to curved nature of the surface. Okay, the surface is, because you know that there is a flatness at the pole now. So due to curved nature of the surface, the winds are, air is not allowed to effectively stay on the ground. Okay, and are deflected outside, creating low pressure. This is first factor. Getting well now? This is first explanation. Due to curved nature of the surface, the wind not effectively stay on the ground and are deflected outside, creating low pressure in this zone. This is first factor. And second factor is, okay, this is first factor. Second factor, you see, this zone, that is 60 to 65, is the zone of convergence of westerly wind and polar easterly wind. Getting well? You see, this is westerly wind is warm and it is cold enough. You know that when two air mass having contrasting character converge along a line, then front formation occurs. So, as a result of convergence of westerly wind and polar easterly cold wind, front formation occurs in this zone, right? Front formation. A front is formed in this zone. Okay, front formation occurs in this zone. And when particularly front formation occurs, you see, due to the convergence of, suppose this is westerly wind and this is polar easterly wind, a front formation occurs, and as along the slope of the front there occur upliftment of the air, and whenever there occur upliftment of the air, certainly low pressure is created. Getting well now? So this is the second explanation given for origin and development of the low pressure between 60 to 65 degree latitude in both the hemisphere. Getting well? In southern hemisphere, subpolar low pressure belt is almost continuous, but due to unequal distribution of the land and the sea in northern hemisphere, the subpolar low pressure belt is not continuous. It is highly fragmented, okay, and remain in the form of cell, air cell, right, and is known by different name in different parts. Like you see, in Iceland, it is referred to as, near Iceland, it is referred to as Icelandic low, okay. Near particularly Aleutian Island, it is referred to as Aleutian low, right. So Aleutian low, Icelandic low, are the example of, are the part of subpolar low pressure belt. Getting well, subpolar low pressure belt. It is the Aleutian low, Icelandic low, right? In North America, it is referred to as Albert low. So Albert low is the part of subpolar low pressure belt. Icelandic low is the part of subpolar low pressure belt, right? Actually, Aleutian low is the part of subpolar low pressure belt. Getting well? What is the actual position? Getting well, right? Now see, actually the last pressure belt is polar high pressure belt. So polar high pressure belt is thermally induced pressure belt. Getting well? You know that angle of insolation is minimum near the pole. So because the angle of insolation is less than 30 degree and somewhere it is almost zero, because the solar radiation insolation is almost parallel to the surface. Okay, that's why you know the angle of incidence is more than the critical angle, and hence total internal reflection occurs, and due to total internal reflection, the imaginary figure of the sun is formed, which remain particularly there for almost 6 months. That's why it is said that's why Norway is referred to as land of midnight sun, because sun even particularly appear, imaginary figure of the sun appear even in the night, right, is visible in the night. Getting well now? So you see, due to low temperature condition prevailing there, right, actually air remain in condensed form, forming low pressure, forming high pressure in the polar zone. Getting well now? So it is clear that we have 7 pressure belt on the surface, right? They are alternatively arranged. Okay. Again, pressure belt in southern hemisphere is more continuous, and pressure belt of northern hemisphere is not less continuous, right? In southern hemisphere, it is due to dominance of water, homogeneous nature of the surface in southern hemisphere, and in northern hemisphere, due to unequal distribution of the land and the sea, they remain in the fragmented form. So what is the actual position of this area? It is clear now, right? Now see, actually here the 3 cells are produced in northern hemisphere and 3 cells are produced in southern hemisphere. You see, this is A, this is A, right? A is formed between equatorial low pressure belt to subtropical high pressure belt, because the air uplifts from equatorial low pressure belt and descends downward between 25 to 35 degree and returns back forming the cell. Okay. So this cell was first noticed by Hadley. That's why A is referred to as Hadley cell. What is Hadley cell? It is clear, na? The cell formed between equatorial low pressure belt to subtropical high pressure belt is referred to as Hadley cell. Okay, right? Second pressure belt is between subtropical high pressure, subpolar low pressure belt to subtropical high pressure belt. This is B in both the hemisphere, right? You see the condition of B. When A is referred to the Hadley cell or tropical cell or lower latitudinal cell. There are three names given to the Hadley cell. Okay, one is Hadley cell, second is lower latitudinal cell, third is tropical cell. Getting well now? Second cell formation is between subpolar low pressure belt to subtropical high pressure belt. This is the second zone. Okay, this is referred to as feral cell or middle latitudinal cell or temperate cell, right? Either feral cell or middle latitudinal cell or temperate cell. Getting well? And the third cell which is formed between subpolar low pressure belt and polar high pressure belt. This is C1. C. It is referred to as polar cell or higher latitudinal cell. Okay. It means three cell formation exist in the northern hemisphere and three cell are formed in the southern hemisphere. Getting well? So this type of air circulation is referred to as trimeridional air cell formation. Getting well? Okay. When you will go through the cell formation, right, you will analyze the cell, you will find, right, here you see this, how particularly cell formation occurs. It is clear now? We have, in every cell we have four components. In every cell we have four components. Okay, this is first component. Suppose this is your surface. This is first component, this is second component, this is third, and this is fourth. First, second, third, and fourth. In every cell, you see. The first is referred to as surface wind. Second is referred to as ascending column of air current. Third is referred to as subsurface wind. Fourth is referred to as descending column of air current. We have four particularly components in every cell. Right? First is surface wind, second is ascending column of air current, third is subsurface wind, fourth is descending column of air current. Getting well now? In every cell we have particularly four component of the cell, right? You see in number in A, that is Hadley cell, this is particularly surface wind component, right? The surface wind component of Hadley cell is called trade wind. Getting well? Right? Trade wind is the surface wind component of the Hadley cell, right? And it comes from subtropical high pressure belt to equatorial low pressure belt. Okay? Again, you see the surface wind component of feral cell is the surface wind component of feral cell is the surface wind component of the feral cell is westerly wind. Getting well now? And westerly wind blow from subtropical high pressure to subpolar low pressure belt. Getting well now? This is second component. And the third cell, the third one is polar cell. See, so its surface wind component is referred to as polar easterly. Polar easterly. This is polar easterly, right? So polar easterly wind is the surface wind component of the polar cell. Getting well now? So actually, when you will draw the figure, now actually on the map you will find, you see it is clear now. Now see, if this is pressure belt on the surface, and this is 0 degree, and this is 10 degree north and south, this is 0 degree, and this is 0 degree, this is 10 degree north and 10 degree south. Okay, this is 23.5 degree, this is 23 and again 25 to 35 degree. Right, and this is particularly 60 to 65 degree, 60 to 65 degree, right? In northern hemisphere, this is northern hemisphere, this is 90 degree. Getting well now? This is northern, this is northern, this is northern. Okay. In southern hemisphere, you see 25 to 35, 25 degrees south, 2 to 35 degrees south, Okay, this is 60 to 65, 60 to 60 degrees south to 65 degrees south, and this is 90 degrees south. Getting well, 90 degrees south. Okay, polar high. So actually here low pressure is due to upliftment of the air. So air uplift here, divert here, descend here, return back. Okay, same is the character in southern hemisphere. This cell, this is A, which is referred to as Hadley cell, tropical cell or lower latitudinal cell. This is low pressure, the wind uplift, divert, descend, again return, forming B cell. From this low latitude, actually the wind descend, divert, this is B now. Okay, getting well? And this is again the wind descend here and forming C cell. So we have three cells on the earth surface, right? A is referred to as tropical cell, B is referred to tropical cell, Hadley cell or lower latitudinal cell, B is referred to as spiral cell, middle latitudinal cell or temperate cell, and C is referred to as polar cell or higher latitudinal cell, right? So what is pressure benefit is almost clear now, and which zone will record particularly rainfall, it is clear, right? Since front formation occurred in between 60 to 65 degree latitude, so that's why most of the rainfall in between 60 to 65 degree will be in the form of frontal rainfall. And equatorial zone, since you see intense convectional phenomena occur, so that's why particularly this equatorial low pressure belt record convectional precipitation. Best of luck, right? You retain it. It will be highly helpful for optional as well as GS. Okay, and will be helpful for understanding another topics. Best of luck.